Welcome everyone. My name is Karanbir Singh and I'm a sports psychologist. I welcome you to our eighth episode of Sports Psyche Talk. We have with us a very special guest, Mr. Lee. Mr. Lee been associated with Neurotracker and he been involved with the company past around more than 10 years now. And so we will uh, try to discuss the neurotechnologies in sports. Uh, so I would like to welcome you, Mr. Lee, to our podcast, and I want you to share your background with the audience first.
Okay, pleasure to be here, Karanbir. Yeah, so sure, yeah, I'm very fascinated in the area of neurotechnology, neuroscience, and sports performance and high performance generally. So yeah, I work for Neurotracker. Neurotracker is what we call a tech transfer company. So we partner with the Faubert Lab at the University of Montreal. They're a psychophysics lab, technically. They work on human perception, and they actually produce some technologies that are fairly breakthrough technologies. And then we as a company come in to commercialize those technologies and take them to market, involve them and work in research groups. So company founded in 2009, I was there at the beginning. So I actually did a bit of consultancy work, sports science consultancy for Manchester United Football Club. And they actually asked me to go out and find a cognitive training solution. And of all the things I kind of researched and explored, Neurotracker seemed to be the one that was the most likely to be a good candidate. They liked it and the company founded, and then we started off working with elite sports, and then the company sort of grew kind of globally as well. Now we have about 1,500 performance and rehabilitation centers around the world that are using Neurotracker. And then we also work with a lot of sort of industry clients like the US Air Force and NASA and different groups, and quite widely diverse now, especially in human performance. So it's like esports, elite military, F1 racing. I've actually worked with Red Bull Racing team myself personally. And then on the other side, we have sort of Neurotracker being used as sort of cognitive rehabilitation or just quality of life enhancement. So for kids with neurodevelopmental disorders like ADHD, OCD, and the whole spectrum, there's lots of research to show it's beneficial there. So in terms of learning education, and then also for sort of cognitive impairments. So there's a lot of research done in concussions and concussion recovery management with the tool. And then in neurodegenerative diseases, so things like mild cognitive impairments, Alzheimer's, things like that. So it's quite wide, quite diverse. So actually the research now is about 130 studies that have been published in the last 15 years. All of them independent. So we as a commercial company don't fund anything or have any control over the research. It's all sort of organic. And it's developed. But part of my role is to help sort of collaborate with research and different institutes around the world. So I'll get to have a lot of exciting conversations with nutritionists and sports psychologists and all sorts of different people. So yeah, that's the kind of gist of my role. So I'm technically a director of concept applications. So I work at the science level and then try to kind of transfer what are the findings that have been discovered from science, because we're a very science and R&D company, and the science has always led the way in terms of how the companies evolve the product, and then try to apply what those scientific findings are to real world applications for different industries and different contexts. So yeah, that's the kind of gist of what I do for Neurotracker.
Oh my God, actually, this is quite a comprehensive introduction, and yes, actually, I can simply, kind of amused by this introduction. Uh, Mr. Lee, actually, I just wanted you were talking about your involvement with the academic institution at University of Montreal. And I understand because we have Neurotracker technologies. There are institutions in India, those are using neurotechnologies, especially Neurotracker, especially your vision training board, if I'm not wrong. So can you please, step by step or point by point, name these technologies or products which are available, and if there's a product called vision training board, how does that?
That's not us, but actually, so tools like that are often used in conjunction with Neurotracker because it works well with lots of other tools like Fitlight and so on. So yeah, but it's not actually our product. We do have other technologies, some of them sort of partly commercialized, but we're actually most of our presence on the market is just around Neurotracker products and how people integrate
So
with other.
yes, so that is what I'm asking for our audience. If you can name those technologies or products, and if you can one by one share, what are the benefits or uses of the products, and especially in sports, because I work in sports, especially in sports psychology. So there might be some products which are related to sports psychology or psychology, both from evaluation and training point of view. And then there might be some product those are more into the neurosciences. As you were talking about the concussion. So if you can please name these technologies or Bleak products and their benefits and uses, that would be nice.
Sure, I can give a broad overview. So Neurotracker is fairly unique because it's kind of a simulation-based form of training. We're trying to replicate some elements in the real world and how the brain processes them. So it uses 3D technology. So it's kind of in its own space. There's not really many other products that kind of relate to Neurotracker or follow the science as we do. But that's a type of technical we call perceptual cognitive training. So we're actually using vision as the modality to stimulate brain functions. But with this particular task, because there's complexity, we do multiple object tracking. We do it across 3D space and across a wide sort of field of view. So it engages a lot of the visual cortex at the back of the brain, but we see from QEEG studies actually involves a lot of integration of those systems. We see stimulation of auditory processing, we see the frontal lobes activated, and then with all the studies that have been done, we see really strong near transfer effects, such as improving lots of different high-level cognitive functions across the brain, and then we see far transfer effects, such as one study showed that 3 hours of Neurotracker training produced 40% less decision-making errors in competitive soccer play. Another study showed for like competitive swimmers, and if they did 3 hours of training, it reduced their reaction times off the blocks by twice as much as doing 6 weeks of dive reaction training. And then just recently, actually, there was a study done with Japanese professional baseball players. They trained on Neurotracker across the season, and across the season, they tracked all their competition statistics. And at the end of that, it showed that when it came to like the complex pitches, like curveballs and sliders, that the batters could actually hit 12% more shots, but also the pitchers ended up with 25% more strikes, so they made the pitcher less effective. So we see this combination. So it's kind of a little bit unusual because it's a visual training tool, but actually it integrates a lot of different brain functions, and that shows that we have the neurobiological evidence of the significant effects. We have the near transfer effects and neuropsych assessments. We have the far transfer effects from various studies that are done across the board. But outside of that kind of perceptual training domain, they're sort of low-level visual systems. So if you see a flashing light, you have to respond to it quickly. There's not a lot of brain activation involved in that. It's fairly automatic. It's kind of difficult to improve that because there's not a lot of neuroplasticity involved. However, they're pretty much always paired with complex motor skill reactions. So these are sort of tools that are using the cues. They're still stimulating things like peripheral vision at a low level. You able to detect things visually on a fast time scale. But a lot of it is the complexity is actually responding to it and reacting and moving and coordinating to respond to that target. So there's a whole slew of technologies that use that. They go back to probably like the 1980s, starting off with like BATAC. It's like the time reaction test to flashing lights. And then the other areas, they're kind of quite small still. So I'd say you've got the sort of neurostimulation technique. So you have things like electrical stimulation. So there's various devices on the market for that. Patterns and start to learn with that feedback how to control those patterns. You can have more self-regulation over your brain function, so you can either remain in a calmer state or maybe get into a peak flow performance state. And then outside of that, you've also got just what kind of classic brain training tools. So these are mostly software-based, so things like Lumosity and Brain HQ. So these tools were originally developed out of neuropsych assessments. So the tools that are designed to test very specific functions in the brain, such as a certain type of working memory. Then most of those software tools, when you do them, you just do it on a normal computer without any other equipment, and you'll go through a slew of different games that are all essentially some different sort of neuropsych assessments turned into sort of training exercises. The evidence for those is there's some companies that have good evidence, but a lot of the companies don't do any scientific research, and there's quite a lot of criticism that they improve some of the very specific skills that are trained, but it doesn't transfer to other domains. And outside of that, you've also got, you combine these days tropics and different sort of diet regimes, hydration plans with sort of biofeedback technology and smart technology to basically, sleep performance as well. So those are the kind of broadly areas where technology is coming into the human performance domain. But our space is most of the perceptual cognitive training.
Yes, I think it's great. Yes, the perceptual cognitive factors are really, really important parameters when we talk about performance in sports, uh, especially the visual skills and then the processing and adaptive skills, the entire combination of all these skills. So, yes, definitely, that is one area where I think still many sports psychologists, those who are a little bit experimental about the cognitive perceptual skills, and those
Yeah.
who try to think outside the box when it comes to the high performance, how they can improve the performance of the athletes. So these are some of the areas I think they can dive in. Uh, um,
Actually, to give you
so
one example of that, because I think actually combining the sort of neurotechnology and different techniques, like I just mentioned, with sports psychological techniques is very good. And we had a client who was a sort of gold hockey tender in Canada and played at the collegiate level, but she started training with Neurotracker sort of every day for about 5 years. She made it to the national team and went to the Olympics and won the gold medal. But she uses Neurotracker specifically to fuse sort of the, visualization training with the pressures of cognitive training in our system. So before she goes into competition, she'll start to visualize, say, doing penalty kills while she's doing Neurotracker at the same time. And she's had fantastic results. And I think it's a good example of the synergy you can get when you find different methodologies of training and different paradigms into one training approach.
so I was just thinking, yes, but yes, you just gave an example of how ice hockey player combined, the Neurotracker training over the period of time. Any training do need a consistency. You have to be very consistent with these technologies and the patient as well. These are some of the challenges in sports where an athletes, those who are driven and those who really understand the importance of the use of these technologies, they are the one who may spend time training with these technologies in order to basically gain that 1% marginal gains during their matches or their competitions. Uh, Mr. Lee, I was just wanted to. I've been myself using some of these technologies past few years. Uh, you know, you talk about the attention domain, so there were like many types of different attention styles, or we can say type of attentional focuses. I was working with the hockey players, so I was assessing them on their time movement anticipation, on their reactive ability, divided attention, sustained attention, all these things. Uh, One challenge which I always face the practicality of these modules, I'll say, or these not a technology. Technology itself is now established because those who really understand they are using this technology. Um, my question is the applicability of this cognitive perceptual skill training on field, or it is still a lab based procedure.
So this is where, I probably should kind of give a little bit of overview of Neurotracker. It's a 3D multiple object tracking task where you have to track 4 targets simultaneously moving in 3D space amongst lots of other spheres that are distractors. So we have 2 sort of phases of the training line. One is what we call consolidation phase, where you just do the basic core exercise, sitting down, no distractions. You go through that, and everybody gets a rapid learning rate. So everybody improves at this very, very quickly. And we know the changes, improvements in the scores are pretty much directly correlated with increase in neuroplasticity and brain functions, from all the evidence. And then once you kind of gone through this learning phase, then we have a second phase, which is kind of what we call the dual task phase, The dual task phase is where you do Neurotracker and another activity simultaneously, which is because the task itself is dividing attention across 4 targets. Initially, your scores go down, you see Neurotracker scores drop, it's very difficult, but again, we get another rapid learning phase, almost like another consolidation. And then you do a more difficult task, and then you improve again, more difficult task, you drop, improve again. Then over longer time period, you can end up training the ability to do some extremely complex tasks. I mean, with the US Air Force, they actually did barrel rolls in jet fighters while doing Neurotracker at the same time. So that's a sort of training methodology. But when you bring in the dual task, you can go from being very general with Neurotrackers and integrating a lot of different systems in the brain to honing it to very specific skills. So I want to be able to do stick handling for hockey under pressure, like simulating game demands. It's even been used in research to detect the risk of getting ACL injuries, because it's only when you put someone under cognitive pressure, like with a task like Neurotracker, the research actually shows that only then do you reveal these weaknesses in motor skills where you can inflict a self-injury on yourself. So yeah, it's the kind of dual task phase, and there's no real limits to that. As long as somebody can perform a task, it doesn't have to be physical or skill-based. It could be auditory, for example. As long as it can perform a task while doing Neurotracker at the same time, then we have this ability to make it much more sport specific, and we have a more powerful tool for very sort of enhancing what the sort of breaking limits of an individual's performance is. So for example, in the military, they use it to test weapon handling skills under pressure to see if they have to perform the task, so they do it without any Neurotracker. And with, they also did like a close quarter battle scene study where they actually did dual task training with Neurotracker specifically to see if it would reduce casualty rates in things like room clearing, where even like, you know, the world's best sort of special forces, they tend to have about a 50% casualty rate in those scenarios, and they produce really nice results from it. So yeah, you start from general and go to specific is, I guess, the answer.
Okay, yeah, yes, this is really important. One thing which you have just shared with us, that whenever basically you try to apply the training, uh, or use these uh, technologies on the athletes, you start with the basic module first, and then you
Mhm.
gradually see how the athlete basically perform, and then you progress according to the difficult one. I just wanted to ask, I've been using, my question was around, Mr. Lee, that the practical aspect of it. I recently testing evaluated athletes on one of this vision training platform, where I have a test multiple object tracking is there. Um, then there are some peripheral reactions. Then there are some central reaction. So there are a variety of uh, a test available with me. I'm unable to basically formulate a kind of program where I see the similarity of such same kind of training while they are actually training on ground. Uh, how it is correlated with their performance in the training and in the competition. I know they, maybe ability to of the ability of the athlete, basically multiple object tracking is slightly to, or it is poor, or 20%, 30%, not really significant. Need an improvement in that area. And then comes the perception. So these are area where athletes scored low. So I wanted to know how basically we can evaluate the progress we see here in the lab is amazing. Okay, they have done 12 session with me. Now they have improved. I see, okay, I can go easily to the coach. I can tell, okay, no, see, coach, this is I have done. This is I have evaluated. Now you see this, your athlete improved on this particular parameter, cognitive perceptual parameter. Coaches are sometimes not really convinced, because they be like, how it is reflecting on in real situation. You tell me how it has improved. So have you gone through such kind of experience where you had an argument with the coach, and then you have to kind of convince the coach, just see what I have done some amazing job, why not you
Well, you
just
try to
recognize it?
tackle one of the hardest questions in human science, really, which is to measure fire transfer. So when you measure fire transfer, especially in high performance domains, there's a whole lot of things that are in the mix. One, the complexity of the performance is very difficult to assess. For example, if you wanted to measure a soccer player's performance, you have to take into account that their performance is relative to the team's performance that they're against. You know, if they're against an easy team, they'll play completely different to against a superior team. The other thing is that, you know, in terms of the training effects, you're rarely ever just doing the one thing. You're always doing lots of other things. So this is like one of the questions in, you know, human science research is how do you isolate one, the sort of training intervention stimuli, and two, how it influences, you know, real world behavior or performance. So yeah, there's a lot of our clients who do their own case studies, lots of different methodologies, but really we kind of have to turn to the scientific studies to measure that, because it's the scientific studies that set up the methodologies very carefully and sometimes very intricate methodologies to, you know, narrowly isolate to say, okay, we train this, we've done a placebo test, and we don't think there's anything else in some performance other than this, and now we're going to see how it affects performance. So for example, you know, I mentioned the swimmer study, dive reactions, they isolate everything else, you know, and they actually simulated competitions. So they actually had, you know, real competitions, but they have very accurate equipment. They can measure every, you know, the dives very precisely. We had like a fatigue study done with like world-class rugby players where they actually looked to see the effects of, as we know, the effects of physical fatigue diminishes cognitive abilities. So you have athletes in the second half of a game like rugby or soccer or hockey, they get fatigued, their decision-making process becomes poor, and usually it's errors that decide the outcomes of games. So they actually isolated, you know, the effects of what is the impact of fatigue on the athletic brain under, say, an hour of intensive 80% VO2 max exercise, doing pre-post measures, so you know there's nothing else. And then they actually look to see if you were pre-trained on Neurotracker compared to just doing a baseline, what is the difference? Is there any difference? And in that particular study, it turned out that if they weren't pre-trained on Neurotracker, when they actually did the exercise, the, you know, situational awareness capacity had dropped, sorry, like 35%. But if you were pre-trained on Neurotracker, it only dropped about 1%. So there you have a very clear measure that when you're getting physically fatigued, you're minimizing the impact on your cognitive abilities. And that's the only real way to do it, is the hard way, is to methodologically analyze the training that you do and isolate it, and then do very strict measures of it. These days, you know, in sports like basketball and other sports, you have, and soccer particularly now, you have fantastic performance analytics that you can get in professional games. So you can analyze a lot of different factors, you know, the speed, velocity of players, number of tackles, interception, so on. And there's even AI being used in that analysis now, so those tools will become more powerful. Yeah. So as we go
Yes,
forward,
actually, yes.
yeah, a lot more
Yeah,
intelligence on the actual
a
performance
lot
side.
of, you know, I don't know actually how to express this feeling of, especially, oh, you know, the AI basically is a game changer at the moment, and it is just taking over everything. Let's see. We have to look at all these technologies or new innovations in a different positive way. Um,
Mhm.
it is only to better the world. Uh, I think you have prepared some of the slides. I forgot. You want to show our audience some of
Cool.
slides you prepared.
Yeah, so I'll just go to share screen. Okay, is that coming up?
Yeah,
Yeah.
yeah. Yes, yes.
Yeah, so this is an overview I mentioned before, introduced Neurotracker, tech transfer company. We have a lot more sensors than what's on the map at the moment, but yeah, we work with a diversity of clients who've been around, and we're very much a science and R&D driven company. So this is essentially the Neurotracker exercise. It's really, really simple. So it's a multiple object tracking task. You presented some targets out of a number. They're highlighted, and then it will move amongst each other, get jumbled up. You have to remember them, track them, then identify them. If you identify them wrong, the next little test will be slowed down. The speed will be slower. Speed is a primary way to modulate the difficulty. If you get them all correct, then the next mini test will speed up. If you get them correct again, it'll speed up logarithmically or exponentially. And with this approach, we do 20 mini tests, and it comprises one session. It gives us a speed threshold result at the end. So over that course of that session, most people within about 60 seconds or 1 minute, they'll be at what we call their speed threshold, which is their kind of breaking point for their upper limit for tracking speed. So that on one trial, they'll fail, the next trial they'll succeed, and then we get a sort of seesaw effect where they're succeeding and failing 50% of the time. This gives us a measure of the sort of upper limit for breaking point and the attention resources used for this task. And that measure itself turns out to be a really powerful indicator for real performance, cognitive conditions, things like that. And then with this training paradigm, you do 6-minute session. You can do up to 3 sessions a day. We
So
see
this is
that.
sorry, but this is like a multiple object tracking only.
Yes, so the multiple object tracking has been around in psychophysics research space for a long time, but this is a specific variation of it developed at the Faubert lab where we use speed as the modulator, so it's much more sensitive. Like other, previous versions just use things like adjusting the number of targets, for example, or the length of tracking time. But the critical factor is we have it in a 3D environment, so it's a 3D simulation essentially. So we can use VR headsets, 3D TV, 3D projectors, but most of our clients just use the anechoic glasses that we've engineered specifically for the software. You put those on, you can use a home TV or whatever, and then it converts your display into true stereoscopic 3D display. So once you have this 3D component with the rest with the other factors, then even though it looks very, very simple on the surface, and can probably just run through quickly, it's actually a bit more sophisticated. So the first thing I mentioned is the stereo 3D. So I'll just clarify, it's a little complicated here, but 3D perception involves a lot of different systems. So you can tell how far away something is, for example, by the size of it. You can tell sometimes by the speed, velocity, the tone perspective, there's all these different systems. But the most powerful cue that the human brain has for depth perception is what's called binocular stereoscopy, and this is specifically the different viewpoint between eyes. With that different viewpoint, the brain can do trigonometry to calculate very accurately the distance of depth of objects and also their velocity in space. And we know that the sort of stereo for vision is really important. The obvious reason is we have 2 eyes and we have a different side of the brain working with different resources from each eye. That's very, very costly from an evolutionary standpoint, yet almost everything in nature has 2 eyes specifically to get this 3D stereo perception. The other reason is that when you process visual information, you might not realize, but light comes in through the retina, and then even neurons at the level of the retina start filtering out and segmenting the information within that light. For example, there's information about what an object is, its color, its hue, its contrast, its movement. All these things get separated and segmented, and then they get filtered different regions in the visual cortex for independent processing. Once all those different features have been processes, they get built back together, and then the brain constructs a simulation of reality. It's what's called the internal model, which generate reality from different parts of the sensory cues that we get. And in that process of building back together, the sort of heavy lifting processes are always put in last. They're always the most important. And binocular stereo processing is the last thing to be processed in the visual cortex. So we know it's very important, So that's why it's incorporated in the training. And we think it's actually a key ingredient why we get stimulation across a lot of different areas in the brain, as well as some of the other factors here. Moving sort of from left to right, we have the multiple object tracking. So this is technically what's called divided attention. And attention, especially in humans, is a surprisingly limited resource. So for example, research shows that if you have somebody walking down the street, you ask them to count down from 100 in sevens, they almost always stop walking, because just the act of trying to do that mental arithmetic is competing with the attention required for walking, or even just standing. Somebody might sit down to think, stuff like that. So when you actually do this task, you're actually segmenting your attention across 4 different streams of information. And each of those individual targets will move at different velocities and different spaces and sizes, interact with the other spheres. It will, collide with them. You will get temporary occlusions where it will go out of view, and you have to use working memory to maintain where it is and where it's going to be. So that multiple object tracking is quite taxing. It's something that we struggle with human people. And if you do the task, it's actually quite difficult to track 4 targets at a decent speed. Then we have the wide field of view. So in this task, it's not an eye exercise task. You keep your gaze in the center. We have the visual pivot training for that. And basically what you're trying to do is maximize the amount of information you can process in your peripheral field of view. So even though we want to see detailed vision in the center of our vision, then we still get excellent sort of motion detection in the periphery, but that's a complex task for the brain. So for example, if you're driving a car, you're looking at somebody from the right pulling out, and you know, a child running across the road from the left, yet you're focusing on the front. That's very mentally taxing. So we're trying to simulate that kind of sort of demand on the brain. And then we have the speed thresholds, which is the really important bit. This is the more scientific bit with an algorithm that will adjust depending on your performance, and it will narrow into your breaking point. So you are trained at your upper limit. So we get the optimal training stimulation, and we get a precise measure of your breaking point, and that precise measure of breaking point is really meaningful. It's kind of a Goldilocks recipe, because if this task is too difficult, you don't get any benefits, you don't get useful measures. If it's too easy, it's the same. You have to get it right in the sweet spot for each individual at their current time. So that's the methodology. So when you combine these different characteristics together, even though the task looks very simple, from the perspective of brain functions, it produces some very complex behavior and some really nice improvements in the brain. Trigger neuroplasticity. There's some initial evidence that we actually trigger neurogenesis in the brain, the growth of new brain cells, which can also help with rehabilitation. So it's a surprisingly effective tool. Unlike most what I mentioned, like brain trainers on the market, it's very different because it's a simulation based. So when we give a speed threshold score at the end of the session, which might say be 1.5 for an elite athlete, that is a measure of how quickly they can track targets moving in meters per second in the real world. That's a sort of simulated measure. So the section training within 90 minutes of distributed training, it could be like 1 6-minute session a week, or 3 sessions a day if it's intensive training. We got over 130 studies now that show we get really nice near transfers, a lot of high-level cognitive functions. We got really high improvements, particularly in working memory, actually. And then we see this corroborated with QEEG studies, been several that actually show that these improved functions on neuropsych assessments, we see those changes in the brain. In one study, it actually found that actually some of the effects are a little bit like the effects of taking Ritalin in terms of improving good brain waves that you want to speed up and slowing down, the brain waves you want to calm down a little bit. So it seems to act as a balancing function. Another study in China with soccer athletes showed that actually they used HRV measurements to show that this type of neurotracker training, and only with the 3D, so we can do it in 2D or 3D with or without the glasses, but only with 3D, it induced a state of flow, as in peak performance state of flow. So yeah, it seems to be a very efficient and effective tool, the way it's sort of stimulating the brain with this combination of features of the software. So one of the interesting things, and this is a bit of a personal bias in terms of what I think should be more research in, because we can switch the stereoscopic effects on or off, and we can get the speed threshold measures for both of those individuals, then we can actually measure what we can term complex stereo. So in a optometrist and ophthalmologist, they'll do some stereo assessments, but they'll be very simple, as it'll be a single target, it won't be moving dynamically. With Neurotracker, we know we've got multiple targets moving across the peripheral field of view in 3D space. That's very complex stereo perception. So when you actually do it with the glasses on stereo, we get much higher performance, which you can see in these elevated scores. So there we can isolate and determine that specifically these processes that take the difference in the perspective between each eye, they're very useful. They improve our performance and our situational awareness and how rapidly we can process the complex environments. However, we also see that it can vary across populations. So in children, we see about half as much advantage, but their brains are still developing. The brain doesn't really fully develop until around 25 years. In elderly, which is healthy older people, we see it greatly diminished. So these are heavy lifting resource in the brain. We see that actually some sort of impairment there. So with this tool, we can measure that difference. And interestingly, you would think, in elite, human performance, you'd have excellent complex stereo advantage. But we did a project with the US Air Force training up young Top Gun pilots, and we were brought in to decrease the training time it takes to train new pilots from 12 months to 6 months, which was very successful. But during the course, they did the 2D versus 3D assessments. And out of the 40 pilots or so, there was about 3 or 4 who were outliers who had no stereo advantage. they were basically operating in the world as if they only had one eye. And if you can imagine trying to fly a jet plane with one eye. So that was very interesting. And this may be something to do with younger generations growing up in the digital age, because the brain is very plastic. It's a very use it or lose it. Yet, you know, commonly today, especially youngsters growing up, we spend the majority of our time staring at 2D screens. We're getting no stimulation and definitely no complex stereo. So playing things like sports is excellent, riding a bike, driving a car, navigating complex environments. But it could well be that, you know, this measure can actually reveal how the brain is being impacted by our lifestyles, you know, in which case, you know, Neurotracker is a very good solution for training it. So I'll just tap into very quickly just how this relates to sort of sports vision performance.